So in this video, we're going to look at using the disk method to calculate a volume of revolution where we have a y-axis instead of an x-axis revolution. So it says, consider a dome that is bounded by y equals negative 2/45 x squared plus 90, where distances are measured in feet. Find the volume of the dome. So here's the curve, y equals negative 2/45 x squared plus 90. So it's a parabola opening downwards. So the dome would be established by taking this curve and rotating it around the y-axis so that we would wind up with a dome like this. And what we want to know is the volume of that dome. And what we want to remember also is that the volume, if we have a y-axis revolution, is going to be pi times the radius squared, where we need to know the radius as a function of y. And we're going to integrate over some interval from c to d. So we get pi r squared, the area of the cross-sectional circles, times the height of each disk or a cylinder, but the cylinder heights are just going to be dy, delta y or dy, if we're doing a y-axis revolution. So when I think about a y-axis revolution here, I know I don't need to know both sides of the curve. They're symmetric with respect to the y-axis. In fact, a parabola opening downwards with the line of symmetry on the x-axis has even symmetry. So I just need to focus in on the right-hand side of the curve. And I'm doing a y-axis revolution. So if I draw in a characteristic rectangle, it's going to look like this. And what I want to recognize is that the widths of that rectangle are going to be dy's corresponding to my dy slices. And the radii of each cylinder or disk of revolution we get by rotating this disk around the y-axis, the radii will be given by the x coordinate. So it's the x distance, the horizontal distance is given by x. So we're going to need to know x as a function of y, which will then give us the radius as a function of y, which will be the radius that we slot in here. So there's a sense in which we could say that this is pi from c to d times x squared, pi x squared dy. So x is the radius of revolution, but we need to be able to describe that radius as a function of y because we're integrating with respect to y. So the first thing I want to recognize, because I need to know x as a function of y in order to get my radii as a function of y, is I need to solve this equation for x, and then I'll know x as a function of y. So I start off with my y equals negative 2/45 x squared plus 90. And then I'm going to go ahead and subtract. Actually, I could multiply through by a 45 if I wanted to. There's different ways we could approach this. So I could go 45 times y. So to clear the denominator, 45 times y equals negative 2x squared plus 45 times 90 here. So multiply both sides by 45. And let's let a equal 45 times 90. So that we don't have to drag this number around with us. So I'm going to replace this 45 times 90 with the letter a, so I have something simpler to work with. So we're going to subtract a, which is just 45 times 90 from both sides. And that'll give me 45y minus a equals negative 2x squared. And then to get x squared by itself, we would divide by that negative 2, 45y minus a over negative 2. And what's customary to get this negative out of the denominator is to bring it up into the numerator position and distribute it into the numerator, taking advantage of the fact that if we have negative a over b, it's the same as negative a over b. It's the same as a over negative b. That negative sign can be moved pretty flexibly. So if we bring the negative up and distribute it, we'll wind up with an a minus 45y in the numerator all over a positive 2 equaling x squared. And then, of course, to solve for x as a function of y, we would take the square root of both sides. So we get the square root of a minus 45y over 2. And usually when we took the square root of both sides, we would go plus or minus the square root. But in this case, minus the square root would give us this side of the parabola, and we don't need it. We're going to revolve the right-hand side around the y-axis. So I just need the positive square root. So there's my radius as a function of y. There's my radius of revolution. That describes my x-coordinate right here. So I can go ahead and set up my integral. My volume is going to equal, it's going to be pi times the radius squared, the cross-sectional areas of the circles that we get on our disk of revolution. So it's going to be, my radius is going to be my a minus 45y over 2, and we'll be squaring that, and we have to integrate from, for our dome, we're going to be integrating from 0 all the way up to the peak of the dome, which is at 90. And we could determine that just by plugging x equals 0 into this equation. Plugging in x equals 0 here, we would get y equal to 90 as this point here. So we're going to integrate from 0 to 90. So it's pi radius squared, the cross-sectional circles of our disk, times the height or width of each disk, depending on how you want to think about it. And the widths of our disk are our dy's. This is the width dy, and the height is x, which we described as a function of y. So now we can start simplifying. I get pi times the integral from 0 to 90. We're squaring the square root, so we're going to wind up with a minus 45y over 2 dy. And then I want to recognize that the 2 in the denominator, because it's a constant, can be factored out. And then I'll lock this into parentheses so I don't violate the distributive law. And now I'm ready to integrate. So this is going, the volume is going to equal pi over 2 times, if we integrate a with respect to dy, because a is just a constant, right? A is just 45 times 90. We're going to get a times y when we anti-differentiate, minus, and this y is going to need to be a y squared, so we're going to need 45 over 2, so that 2 is in place to kill the exponent of 2 using differentiation. So there's the antiderivative, and we need to evaluate it from 0 to 90. So I want to notice if I plug in the lower bound of integration, it's just going to zero everything out. I'll get a times 0 minus 45 halves times 0 squared. So I don't need to worry about the lower bound of integration. I'll just worry about plugging in my upper bound of integration. So this is going to be equal to pi over 2 times a times y. Replace y with 90 minus 45 over 2 times 90 squared. And at this point, it's probably convenient to remember that a is just 45 times 90. So if I can replace the a with 45 times 90, which will be times the 90 that I brought in for the y. And then if I look at this, I want to recognize I have 45 times 90 squared minus 45 times 90 squared. So 45 times 90 squared shows up in each of the two terms, which means I can factor it out front. So I really get 45 times 90 times 90. There's the 90 squared, factoring it out to the pi, and it's all over the 2 times, I factored out 45 times 90, which leaves behind 1, minus, I factored out 45 times 90 squared, which is going to leave behind the 1/2. So 1 minus 1/2 is really a half. So I wind up with 45 times 90 pi right here, all over 2 times 1 minus a half is a half, so I get another 2. And then I can simplify. 2 goes into 90 45 times. 2 goes into 90 45 times. So what I see is I get 45 times 45 times 45. I get 45 cubed pi. And this is a volume, so it's going to be cubic units, and I'm measuring in feet, so it's going to be 45 cubed pi cubic feet as my volume of revolution.